All right then, so hello everyone and welcome today to today's SQL Office Hours session. It's always great to be here to help answer your questions about SQL. And I'm excited today because I've got Stew Ashton, who's AskTom disciple and occasional answerer on the AskTom community, who helped me out with a interesting problem we had on AskTom recently. So you want to say hi, Stew?
Hello, everybody. Glad to be here.
Cool. We're glad to have you here. So we had a few weeks ago now, wasn't it, that someone had an interesting problem they were trying to solve. They'd asked a question about trying to solve the longest common substring problem, or the Ratcliff-Obershelp algorithm, which is something I never ever heard of. They had concocted some PL SQL solution involving building 2D arrays, so basically a kind of a matrix of strings, and this was taking them a long time, and they wanted to find the fastest way to do this, find the longest common substring. You notice that I've got a little asterisk on the longest common substring. The problem they were actually trying to solve was the longest common subsequence. It's a very similar problem, but actually slightly different. But Stu might go into a bit more details on that. It doesn't matter too much. But basically, let's imagine we've got two strings like this. So we've got Wikimedia and Remedia. And we want to find the longest common set of letters between them. Now, if you look at these closely, you can probably just about see we've got the MED is the longest one that is in both of these strings. So what we want to do is kind of work through, find a way of doing this so that we can do this pretty quick. I mean, I can't remember how long exactly the original poster took to execute this, but it was too long. They had something like 100,000 rows that they needed to process, and they needed to do it in under a second, or a couple of seconds, and they were nowhere near close to that. So they came and asked us for some help. I offered some advice and said, well, here's a couple of things you can do, and then reached out to the Twitter community. I didn't have time to investigate further and thought, this sounds like an interesting problem. I'm sure there's some smart people on the internet who can help me with this. So Stew Ashton was one of the people who jumped in, and he came up and helped out with solving this problem. So at this point, I will hand over control to Stew, who will walk us through the problem and ways to solve it. All right, then. Do you need me to stop my share, Stew, so you can take over?
Yes.
Okay,
I'll
stop my share.
Okay, so I will share my screen.
There we go.
I know which one. And I'll try and open my PowerPoint at the appropriate point. Okay, is everybody seeing my screen and hearing me?
Got it. Yep, it says LCS solution concept. Got it up.
Okay. So now again, we're just working on the substring problem. Maybe later, if someone really wants to know, I can say what a subsequence is, but that's really just an aside. In the AskTom thread, we only ever talked about substrings. So the concept of this solution is based on what I looked at in Wikipedia, where it appeared that we wanted the longest common substring. And in case of a tie, let's say that there were two substrings of equal length, we wanted the substring the most to the left of the A string. So what I thought of as a concept to solve it was, given two strings, A and B, find a length, a potential substring length, starting from the length of B and going down by 1 all the way to 1. And then for each value of the length, try all the possible starting points, starting from the beginning of A and then going on until there was no more room. And once I had the length and the starting point, do the test to see if the substring of B that I get is within A or not. So if B is SQL, the substrings I would test would be SQL, SQ, QL, etc., etc. So at this point, let me just say that the way the question was the way I read the question, they were more asking for the longest common substring solution and not for the complete solution to this weird pattern matching problem. So I didn't really think about how my solution would fit into some overall scheme of things. I just said to myself, well, why try to fix this complicated PL SQL solution? Why don't I just throw some SQL at it? And I did, and the SQL stuck. I forgot to mention that what I needed to do, or implicitly what I was thinking I was doing, was going through all these possible solutions from the most complete on down, and I would stop then at the first substring that I found, since it's the first one that the solution is interested in. Also, since the idea was to show this substring and eventually to use this LCS function in a more complete solution, I decided I needed to return both starting points and that common substring length. That would be enough to be able to use it again and again if I needed to do further analysis. And we'll see that we need to do that later. So here's the solution, but what I'm going to do is, instead of showing you a slide, we'll switch over to SQL Developer. So here is the input that I'm going to work with for this demonstration. And what I'm first going to show is a lateral clause which simply finds all of the possible substring lengths from the longest to the shortest. So if you can see this lateral clause, I'm using level and connect by to generate numbers. I'm starting from the overall length, and at the beginning, since I add 1 and I subtract level, which is 1 at the beginning, I'm just going to get the length of the B string. And as I go on, I will decrement that number until, as long as the length I wind up with is greater than 0. So in this case, with a longer B string, I execute that and I get all the numbers from 15 on down to 1. So that should make sense. Now, all I have to do then is add another lateral clause, which is going to refer to that length. Notice I have the first lateral clause has an alias of s, and I'm referring to s.len. So if I put those together, I am getting all of the possible substrings that could be common between A and B, from 1 for a length of 15 all the way down to the very end. Now, once I have those things, here's the entire solution. All I'm really doing is saying that I want the starting point, the length, and in this case, I'm not showing the other starting point. I'm just showing what the common substring is. So I only want the common substring when it's really there. If it's there, the result of the in-string function will be greater than 0. So if I run this just like this, I will wind up with all of the common substrings from the longest to the shortest. So I just stop at the first one, and there's my answer. So that was my first shot at just finding the longest common substring. And if you see the slides later, you can see all of the code here. And in this case, unlike in the thread, which I just showed you, in this demo, in this code that I was able to adjust, I also calculate the starting point of the A string. Now, what is it that other people didn't like about this SQL implementation and that I don't like either? One is that I assumed that the lateral clauses would generate rows in order of decreasing length and from left to right. And that is an assumption. Nowhere is it documented that we will actually get those rows back in that order. And basically, every time you assume SQL gives you rows in a certain order, you wind up one day being wrong. Now, if you look in the thread, you'll see a reply called Another Recursive Variant written by Judith Menzel. And she adjusts my SQL solution to order the rows properly before returning the first one. Now, the other thing is that I start with the length of B, and in the example, you see nothing wrong. But if A is a lot shorter than B, I'll be doing a lot of testing that couldn't possibly get a correct answer. So I really should be starting with the shortest of length of A or length of B. Now, at this point, you could ask yourself, was SQL really the right choice? What can be said in favor of it is that SQL will do the job. It can be done using hierarchical queries. It could be done in other ways. And since it's only accessing what is called fast dual, there's really no data access. If you say select some expression from dual and you don't actually access the dummy column, in recent versions of Oracle, it won't really access the dual table. It will know you're just asking it to do a calculation. So it's not such a bad thing really to do it in SQL. Except that, again, I'm assuming what I call a procedural implementation. I want to do the processing in a certain order, and I want to stop just as soon as I get a hit. And that's really always an assumption and therefore a bad assumption if I'm using SQL. And the fact is that there's no data access. It's just a calculation. So, what's the point of SQL if there's no data access? And finally, as we'll see, it's really a very important question how that SQL solution fits into the bigger problem. So let's move on to the pattern recognition concept. This might be a moment to ask Chris if there have been any questions in the chat that are simply concerned with this part.
I don't see any questions at the moment. They say, anyone, if you're watching and you've got questions about this, please just put them in the QA window. I'm keeping an eye on it. So if you need more clarification on what's going on, just let us know and we can address it either as we go through or as we get to the end. But nothing at the moment, Stu. So.
Okay, but I was able to catch my breath. So let's go on to pattern recognition. Now, the concept here is that you get the longest common substring of A and B, get the starting points in each string and the length. Then you add the length, well, more than that, you add all of the LCS variables, length and starting points, of the left sides of each string and the right sides. That is, what's left once you pull out that longest common substring. You're left potentially with a left part of A, a right part of A, a left part of B, and a right part of B. So the idea of the concept of pattern recognition is you need to look at the two left sides and see if there's another common substring. You need to look at the right sides and see if there's another common substring. And if you find one or both, you have to take the lengths of those common substrings and add them to the length you already got. And then you do it again if there are still bits left on either side of those smaller strings. So you just continue recursively until you don't get any more common substrings at all. And once you do that, you have an answer that you can calculate. But let me show you how this recursion would work with a simple example. I've got two strings, and within each string, I can find F, OU, and R. So the first time I run my LCS function, I'll get a length of 2. I'll find OU. I'll get a length of 2, and I'll get starting points at position 4 in both strings. So now I have to take whatever's on the left side of OU, AFB from the first string and IFJ from the second string, and I have to find the LCS of those left side bits, and I find F. So I've got starting points there, I've got a length, and my cumulative length is now 3. So I still have to go ahead and check the left sides and right sides of my smaller strings. So now I'm looking for a common substring of A and I, of B and J, and there isn't any. I've got a length of 0, and that's what stops the recursion. So I've finished with all of the left sides, and I have to do the same thing on the right sides, and I have to keep recursing until there are no more matches. And during that time, I have found a total of 4 characters. Now, the actual algorithm says that once that is done, you multiply the cumulative length by 2, and you divide that by the sum of the lengths of the original strings. So in this case, you would get 4 times 2, which is 8, divided by 16, so the numerical result is 0.5. So that's the concept. Now, as far as what I did, I came up with 2 solutions. This is the first one. So now I'll switch again to try and show you some real code. Now, since this is also called Gestalt pattern matching, it was easier for me to write Gestalt as the function name. So in the function, I'm not talking about A and B anymore. I'm talking about L for left and R for right. And I'm returning a number. And actually, all of the code basically is a recursive function. So the recursive function, which is all in one page here, I've got ln(r), and I've got local variables that are the left, L left, R left, L right, and R right. So that allows me to get those bits that I want to analyze recursively. Okay, now here's the part that if anybody has any objection to this code, don't worry, I object to it too. I'll explain why and how in a minute. So actually, here is my SQL solution for finding the longest common substring. So because I was a bit lazy, I didn't even bother to define a record type for this. I just said for rec in and looped through this SQL statement, even though I knew I'd only get one row back at most. And all I'm really doing is splitting out the left side and right side bits. And once I do that, I return the length plus whatever lengths I get back from analyzing the left sides and the right sides. And that will just recurse through and cumulatively give me the length that I want. Now, except what happens when there's no match? I will not get any rows back from the query. And in that case, I do not return from within the loop. I skip the loop and I return 0. So that should work, and it does appear to work. If anyone knows PL SQL fairly well, you would know that a select which only gets one row really should use the select into syntax and not this loop. And if you'll look in the, I won't skip to it because it'll take me a while. But if you'll look in the thread that we're talking about, you'll see the Judith Wenzel reply. Not only did she put the order by in my SQL statement, but she also changed the PL SQL to do a select into. And in the case where where no rows were returned, she simply had an exception handler for the no data found exception. So she corrected 2 of my errors there. So that'll tell you how it really should have been done. But all this is not important because I really came up with another PL SQL solution, which I think is better. In any case, this does work, and it will return the correct result once I multiply by 2 and divide by the sums of the lengths. So it will come up in this case with 0.588, which is the result that everybody expected. Now let me skip back to the PowerPoint. So you can see that my apology here is also on the slides. Now, at this point, it was reported that this solution was extremely slow. And the reason why is something very important that is probably the main reason why we're doing this presentation. And I will pass not the screen, but the word back to Chris to explain this.
Okay, so thanks, Stu. That was a good walk through your thing. And the point is that we were calling that recursively. So having found with anti-disestablishmentarianism struggle to say the word. What the big long word and the other big long word? We'd found the 4-letter characters DISE, and then we were getting the leftmost strings for both of them and the rightmost, and then repeating the process. So what that means is that SQL statement to find the common substring, we're running it many times. Exactly how many times depends on how many common matches there are and the length of the strings and so on. But we're doing this a few times. And each time we run that PL SQL, we start off with a PL SQL statement executor, runs till we get to the SQL statement, and then it has to do a context switch over to the SQL engine. So these are completely different engines. We've got the runtime engine for PL SQL and the SQL engine. And every time we switch back from forwards from one to the other, there's some overhead. You know, the database has to execute some extra code kind of thing, save like the state of where we are in the SQL or the PL SQL engine as appropriate, shift over, initialize, you know, we're running a SQL statement, parse it, potentially if it's, you know, a new statement, hard parse it, do a whole bunch of work there, get the result, pass it back to PL SQL, and we're doing this recursively, so we're going to end up doing this a few times. Exactly how many times, like I say, depends on the strings and their length and so on. Now, while context switch itself is pretty quick, you know, it's kind of thing happens at the machine level, it'll be very fast. But whenever you do anything lots of times, even if it is fast, it starts to really add up and slow things down quite considerably. And that was kind of what we were finding, weren't we, Stu? The guy, we tested against was it?
The questioner was fine. It was above all, the questioner was finding it. That was the problem.
Exactly. So we did a test of like all objects or DBA objects and comparing some strings against object names. And that was taking a few minutes. And like I say, they needed this to execute in a couple of seconds at most, ideally under a second. So we were having all these context switches slowing things down. But if you just go to the next slide quickly, Stu, this isn't actually, in many ways, probably not the biggest problem with context switches. The biggest problem really relates to functionality. So by default, Oracle Database works with statement level consistency. So when you first start a SQL statement, the results you get, it will show you everything committed up to that point when the SQL statement starts. Now, when we're doing, you know, this recursively and running multiple statements over and over again, we are changing the time that we start these SQL statements. So internally, that works off the SCN, a system change number. Every time we commit to change the database, that counter will increment. There's some other things that will increment it as well. So as we do this recursively, we're changing the start point for the SQL statement. Now, in this case, it doesn't matter. As Stu was saying, he uses fast dual. We're not reading real tables. But in the general case, when you've got SQL inside PL SQL or vice versa, you are querying real tables. And there's always the possibility in a real customer application that someone has changed the data in between reads. So you're actually getting an inconsistent result. You're getting different answers. So this is something you need to be very careful about whenever you've got multiple SQL statements within a PL SQL thing. Particularly if you've got a SQL statement that's got some PL SQL code, and within those PL SQL functions, you then call another SQL statement. This is somewhere where you have to be really, really careful. You're not going to run into these consistency issues. So there's performance overheads and potentially there's correctness overheads. Doesn't matter in this case, but in the real world, it generally does. So I see there's a question from Rachel about how many context switches between a PL SQL and SQL engine is too many. That's a good question, Rachel. I mean, ultimately, assuming that the correctness issue is not an issue for you, and like I say, in this case, it isn't, it really comes down to measuring performance. That's one of those, comes down to what your business requirements are and what you're doing. One thing to be aware of, if you've got a SQL statement and you've got PL SQL in it, the number of context switches is not predetermined. you don't always know exactly how many it is just by looking at the code, because there's various optimizations in the database. The optimizer can rewrite your statement to look like something completely different to what you were expecting. So in general, you can't just look at it and go, yeah, that's how many we're going to get. But ideally, you want it to be so as small as possible. I don't know if you've got any thoughts on that question, Stu?
Yes. And one of those thoughts you just put into my head when you said that SQL will not necessarily call the PL SQL function every time. However, in this case, I think that the most, what seems obvious to me is that if you're going to call a PL SQL function once per row in a SQL statement, which is the case here, if that PL SQL function then calls SQL even once, you've already got a fair number of context switches. You've doubled the number of context switches. And if you recursively call SQL possibly several times in that function, which again is called once per row, then the total number of context switches just explodes. So, and we'll see later on, Chris tested different solutions, and we'll see the impact that that can have. So I personally would say, if you wanted a rule of thumb, and everybody says rules of thumb are dangerous, and everybody, uses them anyway, I would say a rule of thumb would be if a PL SQL function is called once per row, and that function itself calls SQL even once, that's already a warning signal. That's already a lot of context switches. And calling SQL more than once, I would say that's not a yellow light, that's a red light. And I say that after having done it.
Yeah, I think that's a good principle. I think another way to think about it, if you've got the function in your where clause, it is very, very likely it's going to be called for every single row from whichever table it's on, possibly even more depending on join criteria and so on. So when they're in the where clause, it's, yeah, potentially something to watch out for. In the select clause, particularly if your query, your query is going to return relatively few rows, it's fetch first 10 rows only, top end query, you might get away with it. But definitely be very cautious when it's in the where clause, and as Stu says, it's likely to be called once per row. So I see you've got a follow-up question, Rachel. Would it be better to do a cursor with the recursion in a common table expression? So that's a good question, and it relates to another answer actually we had for this, another solution which Judith proposed by putting the SQL inside the with clause. I don't know, do you want to talk about that, Stu, or should we come back to that a bit later?
Well, as far as maybe we can do both. I would just say that, you've got a first, kind of, not really recursion, but a first iteration in the SQL statement that I had. And I did think for a second or two about, how could I put that inside some other SQL to have a pure SQL solution. But, with recursion and the fact that I was already, looping through things just to get the longest common substring, that just got too complicated for my brain. And so I said, no, if it's recursion, I just instinctively thought of PL SQL. And I think to answer more fully will come from our conclusion to the entire presentation, but why not say it twice? Basically, this is all calculation and procedural logic. So why not use a procedural language?
Yep. Okay. All right. So yeah, good
So
point.
am I back on?
Yep. So that's no other questions at the minute. I didn't have anything else to cover on context switches at this point, but if you keep going and show us what's next.
Okay. Well, thanks to Rachel for the good questions. Okay. Now, this is, don't worry too much about this slide because it's here for you to look at later. But before I switch, this is a redo of the PL SQL solution where I use PL SQL to find the longest common substring as well. So the function doesn't do context switches. And this was after getting getting feedback from the original questioner that it was just real slow. So basically, if you look at this Gestalt 2 function, it's really pretty much the same structure. Going back to the bottom, we've got the same return with the overall calculation. We've got this same, much the same idea that we're either going to return 0 or we're going to recurse. The real difference is that instead of doing a for loop or a select into, I'm doing a loop in PL SQL. Before showing that in detail, I just want to mention that I have a length variable that starts out by being the shorter of the two input string lengths. So I did fix that small imperfection that I had in my original SQL solution. So I am now, and again, I do this, I should mention, this bit here and most everything I'm going to talk about, it's all in this function within the function that is recursed. So in this function, if it turns out that I get past a null string somewhere, I return 0. And then I have to mention something here. Here is my loop. Now, if you'll remember from the SQL solution, I actually had two loops. I had an inner loop and an outer loop. Here I also have an inner loop and an outer loop. Here's the inner loop. And here's the outer loop. Now, the thing is, I am going to do a test in the inner loop to see if I got a common substring. And if I did, I'm finished. So I'm inside the inner loop, but I want to quit the outer loop. That's why I say exit the len loop. So len loop is a loop label, which makes sense. But what is a little bit stranger is the way PL SQL tells me to identify that loop. It's with the double, less than, greater than signs that we have to identify the name of a loop if we want to use that name in an exit statement. So I say that because it's very rare that I use it, and it's pretty rare that I see it. So that's probably the strangest thing that you would see. So just to go through the details, and so we have the time, and to make sure that it's not too dense for everybody. I start with, now where do I do this?
What are you looking for, Stu?
Yeah, I start with, I have already initialized this LR length variable to the length of the shorter string. And I initialize the start variable to 1. So when I start, I'm already checking for, let's say in the example that I used in the beginning with my very long strings, at the beginning, my length was 15 and my starting place was 1. So LStart and LR length are already initialized, and I'm just checking to see if using those and getting the substring of L, I find that in R. And that's R start. And if R start is greater than 0, I'm cool. I leave this whole business and I start returning a result. If I don't find it, then I have another exit. I exit the inner loop when my starting point is too far toward the end. If I don't exit the loop, I start 1 to the right and I keep going. And if I never find anything for that length, then once I leave the inner loop, I'm doing some exit or decrementing logic in the outer loop. So basically, there's nothing in here except instructions on when to keep going and when to leave. But the logic winds up being the same. I'm taking the lengths from the longest down to 1. And for each length, I'm starting from the left-hand side and checking each substring until I run out of room. And I either find a result or I don't. If I don't find a result, I return 0. If I do find a result, I recurse. So all that is really doing the same thing as the original, the other solution, except that it's doing it without any context switches. And with that, what are the advantages of this solution? I call it C because the LCS solution is A, the slow Gestalt solution is B, and this is the C solution. Okay, I'm not generating any rows. I'm not doing any fake data access. The starting length is the lesser of the 2 string lengths, so I'm not doing any unnecessary looping. And I am doing things in a procedural order. I'm testing the lengths from longest to shortest. I'm testing the starting point from the left. And since it's in procedural order, I can stop as soon as I find something, and I know that the processing has been done in that order because I control it. I no longer have this worry that the SQL engine could do things differently from what I expect. And there are minimal context switches. There's a context switch simply when the SQL calls the PL SQL function and when it returns. So the result is performance. And I think that's the end.
All right.
So I will pass the word back to Chris, unless there are any questions.
I'm not seeing any other questions at the minute. So, yep. So as we can, do you want me to take control of the screen back again, Stu? Or
Sure,
So,
fine.
let
Well, in
me,
that case, I have to stop sharing. Okay, it's
here
done.
we go. So let me go. So it's, so as we can see, Stu said the result of doing it all in pure SQL was performance. So just to kind of quantify that and show you, I run some basic benchmarks comparing about 57,000 pairs. So like I say, took the object names, distinct object names out of DBA objects, created a table on that, and compared it against some string. And the PL SQL solution was by far and away the fastest, taking slightly under a second, in fact, on average, which was notably faster than the two other kind of main contenders we had. Stu's original solution with the loop, or that SQL statement with all the lateral stuff in, and then doing that recursively. That took about 2.5 minutes, as did UDIS solution, which conceptually is very similar, but approached it from another angle. Rather than using PL SQL as a starting point, it basically had a pure SQL as the starting point. So we've got a recursive SQL statement, and within there, she defined a PL SQL on the fly function. So in the with clause, you can now create PL SQL functions which are local to that SQL statement, and you can then call them just like you do regular PL SQL functions, but you can only use it within that SQL statement. So those two solutions came out about the same, which to me at least is kind of unsurprising, as they doing the same kind of work. They're really doing the same number of context switches. They're just doing them in a slightly different order. So about 2.5 minutes for those. Then to kind of Rachel's question about, well, what about just a pure recursive SQL solution? I had to go at one of those, pulling all the logic out into a pure SQL thing. And that took about twice as long again, so a little over 5 minutes to actually do that. And then Kim Berg-Hansen offered a lovely SQL model clause solution, which if you want to make your brain hurt for a little bit, check out the threads and try and figure it out. I think that's way too much detail for us to go into today. We've covered enough for today, but that took even longer. That was over half an hour for me, so that was even longer.
Yeah.
So now we've talked about the context switches, and that kind of explains why these two middle solutions, PL SQL and SQL, or the other way around, are so much slower than the pure PL SQL. But a lot of you, or some of you, might be surprised that this pure SQL solution ended up even slower than either of those, like twice as slow. And you're like, well, so why is that? Why is the pure SQL solution so slow? And this just kind of relates to some of the things Stu's been talking about. First up, in the general case, we are processing many rows. So we're taking one of those strings and splitting it out into the possible substrings. So we've got a 15-character input string. We've got one 15-character string, two 14-character strings, all the way down to 15 one-character strings, which grows at, rate of n squared plus n over 2. So quickly, it's growing with the square of the number of the length of the string. The bigger that becomes, the longer it's going to take, the more data we are generating. So you can easily get to hundreds and hundreds of rows that you are your potential input data sets. And as Stu's been saying, with SQL, we use set, or the database uses set logic. There are things you can do like fetch first or row num equals 1 to try and stop processing early, but in the general case, there is no guarantee that the database will do that. Quite often you'll find it will generate the entire possible data set and then start shrinking it down. Whereas, as Stu was showing, as he was looping through the pure PL SQL solution, as soon as he found a common substring, you can just stop at that point, right? So this is a big advantage, and it's something that applies to any kind of procedural type algorithm. As soon as the result depends on previous results in the data set or previous logic you've used, or there's some get out early clause, you can guarantee that with procedural processing, whereas it may not happen with SQL, or at least you have to get very, very creative with your SQL to ensure it does happen. And finally, this is more of an implementation detail, really. So Stew used that lateral clause to generate rows. And that's actually a really good way. It's a nice way to say for each row in your input, generate X rows for one of those. So up to the length of the input string, for example. The problem with that is it essentially forces the database into a nested loop join. That's fine if we've got small data sets, but as we can see, as these strings get longer and longer, we could have hundreds, extreme cases, maybe even a few thousand possible combinations. Normally in those scenarios, the database would prefer to use a hash join. Hash joins are generally better suited to larger data sets. When a lateral join forces it to nested loop. So that means for each row we're getting, we're running that inner thing many, many times, potentially. So there's lots of things in here which mean that SQL just isn't able to optimize the solution in quite the way we can control it with PL SQL. So, to kind of cover your point, Rachel, about would recursive common table expression solve this better? I found no. Now, I did have a little bit of a play around trying to change these lateral joins, join them to a real table, like with, 20, 30 rows or whatever, and see if that works out better. Maybe the database could optimize it. I didn't get far enough with that. Maybe someone watching is going to take this as a challenge to see if we can get that SQL solution anywhere close to the PL SQL solution. Gold star to anyone who is able to. I'm not confident myself, but maybe it's possible. So that's the kind of thing. When you've got procedural logic and you are not having to access the table again itself, working in pure PL SQL can be much, much faster than SQL. So something you want to say, Stu?
Yeah, I'd like to add a little something. Could you switch back to
Sure.
the chart for a second?
You want to go back here? Yep.
Yeah. So you'll see the third column, SQL with PL SQL, is the Judith Menzel solution. And what I think makes it a bit faster than the one on its left is the fact that it puts the PL SQL function in a with clause. That allows it doesn't reduce the number of context switches, but when you have the PL SQL in a with clause, the context switch goes a little faster. The database is able to do some optimizations. And it doesn't appear to make much difference between column 2 and column 3. However, today, I decided to test it with the pure PL SQL solution, and it was up to 2 times faster in the with clause than it was as a standalone function. So just a shout out to Judith. She had a couple of corrections and some ideas that did improve the performance in that thread. Now, personally, I have found that going 2 times faster is not always, you don't always have to do something just because it's 2 times faster. In the real world, sometimes it's just not worth it if you've got something that already works. If it's 10 times faster or 100 times faster, then you really want to do it. 2 times faster, maybe not. But it's worth knowing that in more recent versions of Oracle, they have worked on getting SQL and PL SQL teamwork to improve. And I thought it was just worth pointing out that using Judith's idea, I was able to go 2 times faster.
Cool. Well, that's good to know. So thanks, Stu. And I think your point about, doubling performance, except in extreme cases, it's probably not what code maintainability and probably trumps that, right? But when you're 100 or 1,000 times faster, yeah, you definitely want to switch, right? Okay, so for those of, if any of you do want to take the challenge, I see Rachel, you'll say you're not up for that. That's fine. It does require a bit of thinking about. So if you're up for the challenge or just want to read through the thread and follow what we've talked about offline in a bit more detail, you can go to the question itself. So there's a link there. Also, a link to a blog post from my boss, Stephen Feuerstein, who's written a lot about context switches and their overhead and other ways you can avoid that. So check that out if you want to learn more about context switching. I see Anonymous has a question. Will I provide the PowerPoint? Yep. So if you come back to the office hours page, I will provide a link to some slides. I'll do that. And it'll probably be tomorrow now that that's available, but the PowerPoint will be available. The slides will be available for you to review afterwards. See another comment from Judith. I think that Oracle could adopt the pure PL SQL solution to make it into a standard common string. Well, I think if we provided a standard one, we'd probably even do it in C. A lot of the PL SQL objects and things are actually written in C internally, so they could probably get even faster still. If you want to see that, put it on the database ideas forum. We'll see if there's support for something like that. Okay. Any other comments, Stu, before we sign off and say goodbye?
No, just it was fun. So thanks for having me.
No, it was really great, Stu. There's some great feedback. A lot of people seem to enjoy your approach. So maybe I'll speak to you again soon, another time about coming back, another thorny SQL or PL SQL data crunching problem.
With pleasure.
Yeah. To the rest of you, I really hope you enjoyed this. More importantly, I hope you learned something. Stay safe out there, and maybe we'll get to actually see each other in person sometime. Maybe not this year, but in the not too distant future. All right. Thank you. Goodbye.
Bye.